Hi guys, so today we're going to keep going on with compound inequalities. We are specifically going to be graphing the ones that have the word and in between, not just the ones that have or. So let's remember, compound inequalities is when we have two inequalities that are simple with the words and or the word or in the middle. Now, what's special about the ones that have the word and is you can actually write them in a compact form, meaning you don't actually have to write the word and in between, and you can just kind of merge them together to make them look like this. So this is compound inequalities in compact form. So why is it that I'm allowed to do that with the ones that have the word and? So I'm going to just kind of break it up for you guys so you guys can see it. So if I box this part in here, this part matches this part of the compound inequality. So these two make the same statement. If I take that off, if I look at the other one, this other half, this piece actually matches this piece right here. It's just backwards, but it means the same thing. So we're just connecting the two x's and making it one compact inequality all together. And when you do see them like this, it's the and ones. Only thing is, whenever you have compact form, it's always the and these guys are always facing the same direction. You can never have something that looks like this or like that. It just doesn't work out. So if you were to try to draw this, it would not make sense. All right, so let's go ahead and get started with some examples. Let's look at the first example. Now, when it comes to drawing these, I do it a little differently. You'll see why in a second. So let's go ahead and start graphing it. At 4, I'm going to put an open circle. I'm going to choose a lighter color for a specific reason. So you may want to do this lightly with your pencil, or you may have to go back later and erase. So I'm going to put an open circle at 4. This is less than. Notice when I put my arrow, I'm going to put it above. Now for the 0, I'm going to put my circle that's open, and I'm going to go greater than. I'm going to go to the right. So going back to the definition of an and inequality, remember the word and tells me it's an intersection of the two, meaning where they're both hold true. So it's going to be an intersection of the two. So I have to look, where do both inequalities have are true? In this first piece here, you don't have to copy this part. That's true for the first equation. These are the numbers that are smaller than 4. It satisfies that first one. The ones on the right side are numbers that are bigger than 0, so that satisfies only that one. It doesn't satisfy the first one. And means it has to satisfy both. So the intersection is where they're both true, which is that middle section. So my answer is going to be where the two lines intersect. So in this case, I'm going to write out my final answer in a darker color. So I'm going to just overlap these two circles, and my answer is just pretty much anything in between. So this is the standard case of an and inequality. So anything between 0 and 4. So I'm going to write it in compact form, between 0 and 4. In interval notation, 0 and 4 with parentheses since they're both open circles. So again, if you want to go back and erase the part in green here, feel free to do so. If not, it's fine if it stays there, but it needs to be obvious that your answer is the one in red. Let's go ahead and move on to the next one. Same idea. I'm going to put an open circle, closed circle at -3 to the left, closed circle at -1 to the right. Now I ask myself, this is an and, so where do they intersect? This first piece, only one exists. The middle piece, neither exists, they're both false. The right piece, only one of them is true. So there is no place in this intervals, these three pieces, that they're overlapping, that they intersect. So in this case, there's nowhere where both of them are going to be true. My answer is no solution. There's nowhere where the first one and the second one will hold true at the same time. So it's no solution. So there is no interval notation in this case. There's no answer. Let's move on to number 3. At 4, we're going to go to the left, closed circle. At 4 again on top of itself, it's going to go to the right. So in this case, there's no overlap anywhere except at the number 4. So at number 4, they both share the number 4, but that's pretty much it. So my answer is just 1 point. This one would probably be the best one to go ahead and go back and erase. So just keep the part in red, and that's it. So in the left side, I can just write my answer as x is equal to 4. On the right side, my answer is just 4. There's the starting point and the ending point are in the same place, so there's not technically an interval, there's just one solution. So instead of putting brackets or parentheses, we actually use these little guys called curly brackets when you only have individual answers or a list of 2 or 3 answers. All right, let's go ahead and move on to the next piece. So here's number 4. Let's go ahead and graph this one as well. So start at 0. So we're going to start at 0, and let me change the color here. I'm going to put an open circle at 0, and I'm going to go to the right. I'm going to put an open circle, closed circle at 3, and I'm also going to go to the right. And in this case, we can see that both of them overlap in this area. That's where they're both at. If you look above, both of them are in that region. The middle section, only one of them. The left, there's neither one is true. So we're going to go ahead and put our graph. Remember, it's an and, so it's the intersection of the 2. So they both share the number 3 and everything to the right. So my answer is anything that's bigger or equal to 3. In an interval notation, it's only one interval, so we would start at 3 with a bracket all the way up to infinity. Remember, infinity always has a parenthesis. Let's go ahead and move on to the next one.